Hello all, I'm Leena Doltani and I'm the member of group Husky 3. Our group members are Aliha, Bautik, Leena, it's me, Rohit, Sapna and Soumya. We are here to present our project on motor collision analysis for New York. Move on to next slide. Our agenda of this project is aim of the project, introduction to data, understanding data, data cleaning, exploratory data analysis, hypothesis testing, and regression analysis. We'll move on to next. First is the objective of our project. So first, we'll move on to analyze motor vehicle crashes data from New York. So this involves gathering and examining data on motor vehicle collisions in New York City. This data likely includes details like date, time, and location of the crash, the vehicles involved, any injuries or fatalities, and contributing factors. Next is identifying patterns and trends. Next is identifying patterns and trends. So by analyzing the crash data, the project aims to find recurring patterns and trends. This could involve looking for the factors that are common in many crashes, such as particular times of the day, types of vehicles, or road conditions. We'll move on to third is to provide insights for stakeholders to enhance road safety measures. So the ultimate goal of this project is to use the findings from the data analysis to inform stakeholders on ways to improve road safety in New York City. So the stakeholders could include safety measures like traffic safety agencies, law enforcement, and city planners. I'll hand over to my next member, that is Aliha. Thank you.
So the city of the interest for our data is New York, which is a huge metropolis, and it comprises of five distinct boroughs: Manhattan, Brooklyn, Queens, Bronx, and the Staten Island. And our data would analyze the information about motor vehicle collisions in the New York City. The attributes include crash dates, boroughs where the accidents happened, the factors which contributed to the accidents, the types of vehicle which were involved in those collisions, injuries that were sustained, and a few more things. We sourced our data from the New York City's open data portal, and our data consists of 2 million rows and 26 features. Some of the features of our data are crash date, crash time, the boroughs where the crashes occurred, the vehicles which contributed to the collisions, the type code of the vehicles, number of people injured, and the number of people killed in the data. Now, Soumya would explain the exploratory data analysis that we performed and the data cleaning.
Thank you, Aliha. Now I'll be talking about the data cleaning process which we followed, which is really important for any data analysis. Our data was originally from 2014 to until now, but we took it from 2017 onwards, so we can get the recent trends. We dropped few columns which we found that they are not really important for the question we are planning to explore. So the column we dropped are vehicle types, location, on street name, cross street name, off street name. The location, on street name, cross street name, and off street names we also dropped because we found a lot of missing values in these columns, and because we are planning to analyze based on the boroughs and we had enough data on the boroughs, so we dropped these columns entirely to get the better analysis. We also replaced few names, like we had a vehicle type wagon / sports utility type of a car, so we totally replaced it with the sports utility vehicle. Now let's move on to the next slide. Next slide, please. Yeah. So in exploratory data analysis, we did frequency, severity, and contributing factors of vehicle crashes. This will basically set the foundation of our analysis by giving us an overview how often crashes occur. Then we did borough-wise analysis, which borough has the highest frequency of crashes, and then we dive deep into the contributing factor of these crashes. We also looked trends based on year and months, that which months and year had the highest number of crashes. Now let's move on to the next one. and get into the visualization based on our questions. So this was our first question, that what was the overall trend in the number of vehicle crashes over time. So this time analysis is from 2017 to 2024, like until now. We see a stable pattern in the beginning initially, then a sharp decline we see in 2020. That is more likely because of the COVID pandemic, and then it didn't come back to what it was initially, like in 2017 to 2019. We see a slightly kind of a different pattern, which is fluctuating a little bit. Let's move on to the next one. So here we see the crashes, number of crashes, occurred in the different boroughs, and we can clearly see that Brookline has the highest number of crashes. That can be because of the traffic and because of the city planning system. And then we have, on the second place, we have Queens, and Staten Island has the lowest number of crashes. That is because they don't have that much traffic in comparison to Brookline. Let's move on to the next one. So here we see monthly distribution of crashes, and over the years there seem to be a degree of seasonality in the number of injuries. That especially we see the peak in July, June to kind of August, and that is because of in summer months people are more out and more traveling more, and then we see a pattern, kind of a more like a consistent pattern in the winter months, where the crashes are kind of coming down. There is one exception only in April 2020, because that's when COVID happened and there was lockdown. So you see a steep drop here in April 2020, and that has the lowest number of crashes. Moving on to the next one. So this table displays, year-wise injuries and casual, deaths and injuries, what happened from year 2017 to 2024. And again, we see more injuries and kind of, in 2017 to 2019. And that's the same for the deaths. Move on to the next one. So these are the monthly stat for injury count for, it's a cumulative analysis from 2017 to 2024. And here we can see that July, consistently stands out with the highest mean injuries, while February is kind of, has the lowest mean. Now I'll call my fellow Lena to discuss more about it.
Thank you, Soumya. So we'll discuss the most common contributing factors to vehicle crashes. Here are the visualization of it. So first is the driver intention or distraction. I think this is the most common contributing factor according to the analysis. It likely refers to any activity that driver's attention away from the road, such as using phone, eating, or talking to the passengers. Following too closely will be it refers to a tailgating, which is driving too close to the vehicle in front of you. It doesn't leave enough space to brake safely if the car in front of you slows down suddenly. Next is the failure to yield right of way. This refers to not yielding the right way of other vehicle or pedestrians when you are legally required to do so. Last but not the least, passing at the lane usage improper. So this likely refers to improper passing maneuvers such as passing in no passing zone or passing on the shoulder lane. Next slide, please. So this is the average number of people injured or killed as per crash, that is 0.70. Next slide, please. Yeah. So the most common type of vehicles involved in the crash, that is also an important part of the analysis. The most involved vehicle are sedans, followed by sports utility vehicle that are SUVs, taxis, pickup trucks, and box trucks. So sedans, or I think everyone is aware of. So there are four-door cars that are typically have a closed cabin with a separate trunk. And SUVs are the passenger vehicles that combine features of the passenger cars and trucks. Taxis are vehicles that are used to transport passengers for the fare, and pickup trucks are the motor vehicles designed to carry both passengers and cargo. Box trucks are rigid wallet trucks that are typically used to transport cargo. So next will be continued by Sapna. Thank you.
Thank you, Lena. So we will start with hypothesis testing for this project. Before that, I'd like to brief you about hypothesis testing. So researchers all around the world are interested in various types of questions. For example, scientists might want to know whether the Earth is warming up, or automobile manufacturer might want to know if a seat belt will reduce the severity of injury caused by accident. Now, this type of questions can be answered through statistical hypothesis testing. So, what actually is hypothesis testing? In simple terms, it is a decision-making process. It is a guess or prediction we make before starting an experiment. So, once we make a prediction, after that, we make a guess and we start to collect data to see if the guess was right or wrong. Now, in this test, we do series of steps. First, we define a population. Then we state the hypothesis. Then we decide on a significance level. Uh, Most of the times it is 0.05. After that, we select a sample, perform the test, and conclude our results. Now, let's move on to the next slide. We'll start with the hypothesis testing examples. We can move on to the next slide, the one after this. Yeah. Okay. So the first hypothesis that we ended up doing on this project was to decide if there is a significant difference in crash proportions between morning rush hours and evening rush hours. Next slide, please. Okay. In hypothesis testing, when we consider a statement where there is no difference in the variables, it is called null hypothesis. In this slide, you can see the null hypothesis states that there is no difference in crash proportions between morning and evening rush hours. Alternative hypothesis is exactly contradiction to null hypothesis, which will state that there is a difference in crash proportions between morning and evening rush hours. After that, a significance level of 0.05 is set. Significance level is means that we are willing to accept a 5% chance of rejecting the null hypothesis when it is actually true. After that, a test method of chi-square test was used. Now, this test was appropriate in this situation because we have a two categorical variable and we want to know if they are related to each other. Once the R test was done, the p-value that we obtained was found to be very, very, very low than the significance level we accepted, which means that there is a statistically significant difference in crash proportions between morning and evening rush hour, and hence we reject the null hypothesis. Similarly, in this way, we are going to discuss the few upcoming hypotheses. So let's move on to the next one. In the second hypothesis, we are going to look if there is a significant difference in average number of crashes between boroughs in the New York City. In this, the null hypothesis, we will assume that there is no difference in the average. And in the alternative hypothesis, we will assume that there is a difference in the average number of crashes. Okay, next slide. Okay. So in this hypothesis, we will be performing a one sample t-test and a Welch two sample t-test. Now we did two tests on this hypothesis because one sample t-test we have used when basically we use it when we have one group and want to compare its mean to a hypothesized value. So in this test, we consider a mean of 100 and then we try to compare it to the actual data. So when we did this test, we found that significant deviation from the hypothesized mean of 100 crashes per day, and the approximate mean was 90.57. So the test highly significant p-value finds that the Brooklyn experiences fewer crashes than anticipated. In the Welch two-sample t-test, we have so basically what Welch two-sample t-test is that it is used when we have two groups and want to compare their mean, but the variance in the two groups are unequal. So the Welch two-sample t-test here compares vehicle crashes between Brooklyn and Manhattan and reveals a significant difference because the p-value here is again very less than the significance value, 0.05, which indicates the disparity in crash averages between the two boroughs is highly significant. We can move on to the next slide. The third hypothesis we considered in our project is that there is a significant difference between mean number of persons injured between different months. In this hypothesis, we conducted, can we move on to the next slide, please? Yes. So you can see the testing method we use here is the pairwise two-sample t-test. What is pairwise? Pairwise will indicate that researchers are looking at all possible combination of pairs within the dataset. For instance, if I'm looking for in 4 boroughs like Brooklyn, Manhattan, Queens, and Staten Island. So pairwise would involve comparing data of Brooklyn versus Manhattan or Brooklyn versus Queens, and so on. So this is pairwise. And two-sample t-test, this refers to a statistical test used to assess if there's a significant difference in mean between two groups. So a pairwise two-sample t-test essentially involves conducting multiple two-sample t-tests between all possible pairs of groups in our dataset. Now, after conducting this experiment, again the p-value was found to be significantly lower than the actual significance value. So it suggests that we reject the null hypothesis, which means that there is a statistically significant difference in mean persons injured between at least one pair of months. Can we move to the next slide? Okay. This is the fourth and the last hypothesis of our project. In this, we determine whether the mean total injury in the latest year significantly differs from the previous year. Next slide. The testing method here is a simple one-sample t-test. Again, here we assume a value, a mean value, and then we compare the data we have to the value and see if it matches or what kind of difference there is. After the test was completed, the p-value was again found to be very much less than the significance value, which means that we will reject the null hypothesis that states that the mean total injury in the latest year is equal to 0.7. And in conclusion, we are going to state that there is a significant difference between mean total injury in the latest year and the hypothesized value of 0.7. So this was the hypothesis testing we completed on our project. We will move on to regression analysis, which will be explained by Rohit.
Let's start with the regression analysis overview. Since we're done with the initial exploratory data analysis and hypothesis testing on the data, let's deep dive. So our target definition is to predict the total number of victims in the accident using the various features in the data. So total victims, we have considered a total number of people injured plus total number of people killed. And the independent variables, as you can see, there are borough, month, time period, season, and vehicle categories, and so on. So please move on to the next slide. Yeah, feature engineering. So feature engineering is the process of selecting, transforming, and creating a new features from the existing features to improve the performance of machine learning models. And certainly it will help to improve models' predictive accuracy and reduce overfitting. Let's move on to the next slide. Yeah, so here are the features which we derived from the existing features. As you can see, a time period. So in this data set, we had a crash date time column. Based on that, we have made three categories, which include morning rusher, evening rusher, and the remaining time goes to non-rusher. In the season, this feature is created using the seasonal data of New York City, which includes four seasons, basically winter, spring, fall, and summer. Grouping contributing factors. So this was pretty challenging for us as there were around 100 unique values in the contributing factors. So doing dummy variable for such categorical variable is not at all a good practice, which will certainly create a sparse matrix. So we bucketed those categories into major six categories, include human error, vehicle related issues, and technology related, etc. In a similar way, we did for grouping vehicle types. And the last three features, you can see pedestrian involved. Since we had a feature pedestrian injured and pedestrian killed, we derived new feature which contains a binary value, whether the pedestrian involved in the accident or not, while maintaining the data integrity. And we made sure that the target won't leak in the derived feature. And similarly, we did for the cyclist involved and motorist involved. Can we move on to the next slide? So yeah, correlation matrix. So let's see any feature are correlated among themselves. So as you can see, no numerical feature correlated with each other. So there is weak or negative relationship between the variables, as you can see, as most of our numerical features are in the binary format. So let's move on to the next slide, please. Creating dummy variables. So in this process, we have converted all the categorical features to the dummy categories. And for this, we have used a popular package of R fast dummies. And in this, basically all the categorical features, we had a borrow, time period, and season. We have converted them into the dummy variables. Let's move on to the next slide. Trend test splits. So basically, this divides the data set into the proportion for training the model and another for testing the model. So here we have taken the proportion of 70-30, 70% data for the training period and 30% for testing period. Let's move on to the next slide. So model building and evaluation. So to achieve the objective, we have decided we have applied a linear regression algorithm here. Uh, so I'll like to explain you what is linear regression in layman term. Imagine you have a data point scattered around like a stars. So linear regression lines basically try to fit a straight line to those points to represent the overall relationship between the dependent variable and independent variables. And those are the basic three model performance metrics, MSE, RMSE, and R-square. We'll talk about this in the next further slide. So let's move on to the next slide. So yeah, mean squared error. So this is nothing but the average square difference between the actual value and the predicted value by the model. And it is calculated basically by averaging the square difference between those two values. And here we can see our model has the mean squared error approximately around 3.28, which is a very good value. And root mean squared error, this is the nothing but the square root of the mean squared error. And it provides a standard deviation of the errors made by the model in its capacity. And the value of RMSE was around 1.811. And the third metric is R squared. So this metric basically indicates the proportion of the variation independent variable and predicted from the independent variables in the model. Basically, it ranges from the 0 to 1, where 1 indicates a perfect fit, but we won't get that fit model. So in this case, the R squared value was 0.744, indicating around 74.77% of the variance in the total number of victims. It is explained by the independent variables, the one which we have included in the model. So next slide, please. Yeah, feature importance. So feature importance tells us which feature your data have the biggest influence on model's prediction. So there are basically high importance or low importance features. So we can see in our model, there are three features which have pretty high importance: the motorist involved, pedestrian involved, and cyclist involved, compared to the low importance features like accidental factors, substance use, and the vehicle category other. Let's move on to the next slide, please. So this is linear regression plot. Let's see how our model able to predict the total victims. It's a visual representation of that. It's nothing but the scatter plot of actual value versus the predicted value. And the red dot represents the predicted values and blue shows the actual values. And we are seeing less red dots compared to the blue. That's because they're overlapping. And if you see the line doesn't start from the zero, it starts from something greater than zero on the y-axis. So that point is called the intercept. This value is around 0.0063 in model approximately. That represents the y-intercept of the regression line. It signifies the predicted value on the dependent variable on the y-axis. In simpler terms, I would say it's the point where the regression line crosses on the y-axis. So overall, we can say our model fairly captures the relationship between the dependent variable and independent variables. And there will always be some data points that fall above or below the line. Let's move on to the next slide, please. So in future scope, there are additional features we can add based on weather conditions, road conditions, the traffic volume in that particular borough, or the speed of the vehicle before the accident, or driver's age and experience. So those parameters will help our model to predict more accurate results. And in model selection and tuning, we can also try a different regression techniques such as ridge or lasso regression, which will improve model interpretability by focusing on the most important factors influencing total victims. And for that, I think we need to use certain cross-validation techniques such as k-fold cross-validation or stratified k-fold cross-validation. For this slide, I would like to call my fellow Med Paudik to conclude the presentation. Thanks.
Thank you, Rohit. As my fellow member said, we found out that a big reason for these crashes is when drivers are not paying attention, especially during busy times like rush hours. We look at the numbers and saw that some areas like Brooklyn and Manhattan have more crashes than others. Also, the numbers of people getting hurt changes throughout the year and some months. More people get hurt than usual. So in 2024, we noticed a big change in how many people got hurt compared to previous years to fix this problem. So we have some ideas. Let's move to the next slides as recommendation. So first, we need to remind drivers to pay attention, especially when it's busy. We should also focus on making roads safer in places where crashes happen a lot, like Brooklyn. So we want to figure out why more people get hurt in some months and try to make things safer during those times. And also we need to look into why more people got hurt in 2024, and understanding why this happened will help us make things better. So lastly, we have a tool that can help us predict when crashes might happen in the future. This will help us plan ahead and keep everyone safe on the roads. So, and please let's move to the next slides as references. So we got our information from trusted places like the US Department of Transportation and the New York Police Department, and they give us a lots of details about car crashes, and we use tools like the t-test and learn from guides to understand the data better. So this help us make a smart suggestion to make roads safer. Thank you.